Hey guys, this is lesson 3.2. It's solving systems of equations, two equations with two variables algebraically. We'll first look at the elimination method and then the substitution method. So what you do in the elimination method is you eliminate. If you're going to eliminate, the first thing you have to do is you have to have opposite x's or opposite y's. So we can see here 8x and negative 6x are not opposite. 10y and 20y are not opposite. You can either choose to get your x's opposite or your y's opposite. I'm going to go for my y's, because the opposite of 20 would be negative 20, and I know I could multiply 10 by negative 2 to change it into negative 20. So I'm going to multiply that entire first equation by negative 2. So it becomes negative 16x minus 20y equals 36. And that second equation would then stay negative 6x plus 20y equals negative 14. So you can see what has happened is we created opposites. We now have opposite y's. We have negative 20y and we have positive 20y. So when we go and add those two equations together, so step 1 is to get opposites, step 2 is to add together, your opposites will cancel. Add everything else, so now we're sitting at negative 22x equals 36 plus negative 14 is 22. To get x alone, we divide by negative 22. So 22 divided by negative 2 tells us that x is negative 1. Now what we're looking for is the ordered pair x comma y that makes both of these equations work. So we just found out the x value is going to be negative 1. So once we have the x value, to find the y value, we would just plug it back in. Your choice. You can use either one of these equations at the beginning. I'll just go with the top one. So if I plug in negative 1, 8 times negative 1 is negative 8. Still have plus 10y, still equal to negative 18. So then I'm going to solve that equation to find out what y is. So to get rid of a negative 8, I'd add 8. So my 10y equals negative 18 plus 8 is negative 10. Now to get y alone, I divide by 10. So negative 10 divided by 10 is negative 1. So x was negative 1, y also happens to be negative 1. So the ordered pair that would make those two equations work is negative 1, negative 1. All right, let's look here at number 2. So you can see we have 3x, we have negative 8x. Those aren't opposite. We have negative 9y and 7y. So the only thing different on this one is I can't just multiply one equation to get opposites. I'm going to have to multiply both of the equations. So I'm just going to say, let's see, we'll do the top by 8, because 3 times 8 is going to be 24. And then I'm going to do the bottom by 3. So when I rewrite these, I'm going to distribute this 8 on top here to everything. So I get 24x minus 72y equals 27 times 8. I think I'll validate that on my calculator pal here. My calculator pal is not working. It says that the RAM is cleared. Let me grab my handy dandy phone here. So 27 times 8 is 216. So the bottom one by 3, negative 8x times 3 is negative 24x. 7y times 3 is positive 21y. And 13 times 3 is 39. So first step, get opposites. I got my opposites. So when I add them together, my opposites cancel. Negative 72 and 21. 21 minus 72 is negative 51y. Equals 216 and 39 is 255. Oh, running out of room. So to get y alone, I divide that 255 by the negative 51, and I find out that y is negative 5. So now that I have y, so this time I found y first in my ordered pair, y is negative 5. To find x, I would take this y value and plug it back into one of my equations. Doesn't matter which one. I'm going to go with the top one. So I have 3x minus 9 times y is negative 5 equals 27. So we have 3x, negative 9 times negative 5 is positive 45 equals 27. So now I'm at my two-step equation, right? So I'm going to do 27 minus 45 to get the 3x alone. So 3x equals negative 18. And then negative 18 divided by, very pretty 18, negative 18 divided by 3 is negative 6. So I find out that x is negative 6. So my answer would be negative 6, negative 5. That's the elimination method. That's one of the algebraic methods. Now we're going to look at the substitution method. What you do in the substitution method is you are going to substitute, right? So you want to first solve one of the equations for one of the variables. So I can see here, this bottom equation is already solved for y. So I would substitute what y is equal to into the top equation. So I have negative 7x minus 5 times y is equal to 4x minus 6. And we're equal to negative 24. So you can see what happened is we replaced the y with x's, so now we can solve for x. So we would distribute. We have negative 7x. Negative 5 times 4x is negative 20x. Negative 5 times negative 6 is positive 30. And we're equal to negative 24. I would combine like terms. So I'm at negative 27x plus 30 equals negative 24. I would then subtract my 30. So I'm at negative 27x equals negative 54. So then when I divide both sides by negative 27, I find out that x is 2. So now that I know that x is 2, I can plug into either of my equations to find out what y is. In substitution, you're always going to have this one that's solved for what you're looking for. So y equals 4 times x would be 4 times 2, which is 8. And 8 minus 6 is 2. Another one where they're identical twins. The answer is 2, 2. All right, we'll skip over 4 and go to 5. On number 4, you'd have to solve one of the equations first for x or y. I would probably solve this bottom one for y because it has the coefficient of 1. Or I'd solve the bottom one for x because it has a coefficient of negative 1. Those would be the two best choices, I think. Down here on 5, similar, I'm just going to have to make a better decision. I don't want to solve the top one for x because I'd have to divide by 8, and that's going to create fractions. Solving the top or bottom one for y or the bottom one for x would be fine because I divide by 2, and that's not going to create fractions. So I'm going to go ahead and solve the bottom one for y, just because I like to solve for y because it's in slope-intercept form. So when I add the 2x over, I'd have 2x plus 12. So then when I divide by 2, I find out that y equals x plus 6. So now I know what y equals on the bottom one. So since I solved the bottom one, I'd substitute into the top one for y. So I'm going to go up here just for room's sake. So we have 8x minus 2 times, we just found out that y is x plus 6. Still equal to negative 18. So now 8x, we distribute, minus 2x minus 12 equals negative 18. Then I could see I would combine my like terms. So 8x minus 2x, I'm sitting at 6x minus 12 equals negative 18. To get rid of a minus 12, I would add 12. So then I'm sitting at 6x equals negative 6. Divide by 6, I find out that x is negative 1. So I have x to be negative 1. So now I just have to find out what y would be. So again, once you have 1, you plug into the other. So I know that y equals x plus 6. So if x is negative 1, y equals negative 1 plus 6. So y equals 5. So my answer would be negative 1, 5. And that's a little review on how to solve a system of equations with 2 variables and 2 equations using the algebraic methods of elimination and substitution.